Alright, self-test real quick. 25 minutes. Let's go. Not much time left. I'm just gonna go back to the old quiz shit. This prompt is better than the other stuff. It doesn't hallucinate as much, it seems like. Motherfucker. Okay, why did it bring up Python? What the fuck? Oh, this is the God prompt. Oh, that is the God prompt. Oh my. Holy shit. Okay. Yeah, that works, dude. Okay, here's where the fucking learning happens. Okay, we'll go working backwards. Okay. Function templates. What is a function template? A function template is like it's a generic function that uses the C++ template functionality to generate function template overloads, specializations, depending on the argument types that we call the function with. Basically, it saves us the time of having to individually write a specialization with the same shit for those. However, we can still do a non-template function or just an explicit specialization, but probably just a non-template function to handle and be preferred to well, yeah, because if we didn't, then it would still do that anyway. Like if we already had a specialization listed and I did a regular call, it would still do the specialization before going back to the template to generate the shit because we already have the specialization for that type matrix, like that grouping of types that we have. So for that type of call. All right. A function template is a generic, function that uses function template. With instantiates functions, creates specializations of itself to handle or to replace its type name, its placeholder type name with the type from actual function calls. They're used to generate functions for each call, or for each, well, not each unique call, but for each set of argument data types we call the function the primary template with. So we don't have to manually make near identical overloads for each set of arguments. Like an int double version, and well, yeah, int version, double version, etc. That all shares the same generic logic. 1.3 default arguments. Default arguments assign a function parameter with a default value that should a matching argument not be provided, or should the matching argument be omitted in a function call, that default value will initialize the parameter instead of being overwritten by the calls argument. Say we're in a spaceship far away. If we call get time, we might have a default argument for float time. Well, because we used to be on Earth, so we by default want to get Earth's time, but we can 100%, but we can overwrite, we can explicitly overwrite it by providing the planet we're wanting time for in the call. Okay. Deleted functions are used to, or let us forbid calls to function, or calls to specific overloads, i.e. might have overloads that handle int, double, and bool inputs, but we want to forbid calling the function with a character. We can similarly create a for declaration, well, a statement that looks like for declaration, but add in equals delete between the ending parenthesis and semicolon to delete the function. This will no definition needed. The compiler will error if we cool. Right? Function overloading. Function overloading is what? So it's sharing the identifier so that we can call the same identifier and the arguments we use determine which behavior executes. lets us share an identifier among different versions, overloads of a function. That way, the function calls that way the compiler can determine which version to call based on which most closely matches our calls arguments. Argument types, order, and count. And how does it determine which overload to use? There are rules. Overload precedence, I guess. Hierarchy is 1, exact match. 2, exact match after promotion. Exact match after numeric conversion. Exact match after user-defined conversion. 5. Exact match after ellipses, whatever that means. And 6. No match, no matter. No match after all attempts exhausted. Compiler error. In the event that one of those steps results in 2 plus, or we'll just say multiple overloads, or well, multiple exact matches, we get an ambiguous compilation error, which we can resolve by creating the exact match overload we're missing, or explicitly casting the arguments to match more closely to a specific overload. Okay. Type deduction work. I mean, in general, it's just type deduction via auto gives the variable the type of the initializer. Is there anything else? Like, I mean, for auto, we had that the trailing syntax too. So for readability, where we say auto, then at the end, how did we even do that? I don't know. We say auto returning function does some shit, and at the end, it's like the little pointer symbol, a minus and then a greater than sign. Like auto do thing int, or like that, but it wasn't actually returning, so it was fine. But yeah, I mean, I guess we could say, or maybe this doesn't work with void. I don't know though. Oh, it just wants main. Unreferenced because it sees it in the compiler because it exists. There's a gateway, but it doesn't exist. There's nothing on the other side of the door. 10.4 high def. Used well. Use type def and type aliases to, like, what? Improve the clarity into what? Distinctness of different variables. I mean, we're talking about variables because it's an actual type, because it's in something. Well, I guess it doesn't necessarily have to be. It could be unnamed. Like I could say, like using test as int. Excuse me, and then I could just say test. Test 5, and then int main. What was happening here? Oh, oops. Oh, here we go. Well, how do I even have it unnamed? Like, I mean, because 5 is an int, but test nothing is 5. I mean, same thing. I don't know. I don't remember how to do unnamed objects. Okay. 7.3. Narrowing. We convert the value of data type A to data type B, and data with data type B, or with B not, or being unable to hold or to represent all values of A. Can remedy by using const expressions and literals, since the compiler will actually check if that value of type A can be represented in B, and not all values of type A. Also use brace initialization to have the compiler warn about narrowing conversions. Okay. Type promotion is when a narrower data type is converted to a wider, wider type, one with more memory, that matches the standard amount of memory per type of data on our implementation, i.e. put to double or int to, or short to int on most implementations. type slash numeric promotion is safe. Value preserving, so we don't lose any data. Okay. Okay. Implicit type conversion is when we assign value of type A to variable of type B, or to object of type B. Type B. Yeah, sure, right? Where the compiler converts the type A value to type B before assigning the value. You might lose data doing this, if not value preserving via narrowing conversion. Get other issues too, where we don't lose data, but our value changes, like a signed, unsigned conversion. Okay. Assert calls standard abort if its condition is evaluates to false at runtime. All static assert is the same at compile time. Assert is helpful for defining bugs or assumptions, like dealing too much damage and getting modular wrapping. Making sure the character's ID is set already. Static assert is helpful for, I don't know, validating information before compiling. Check. Oh. What, like the overall state? If the program can compile. Assert. Miss this since it's executed at runtime. By defining and debug, which is already done in release builds. Alright, I think that's close enough. Let's use the rest of the time to review. Don't have time to answer all. Mostly. Alright, cool. Alright. And I'm reading only the critiques because I don't want to reread my shit because it's not correcting myself. I'm not gonna reread the whole thing and be like, oh, what did I get right? What did I get wrong? I just want to hear, yo, motherfucker, you messed up. Because that will fix me. Rereading my solutions that were correct won't change anything in my brain. Besides seeing that I'm on the right track. But so will reading the critiques, so I may as well just read the critiques. They write generic code and it instantiates specific versions for each set. Cool. Yeah, makes sense. Type safety, yeah, so we're not handling, shit isn't being implicitly converted to this one function that we're calling. It's instead actually generating its own version that is safer. Like calling a damaged thing with an unsigned int. Well, bro, it'll just make an unsigned int version. That way we don't have to deal with int unsigned conversions. Default arguments are specified in the function definition and are used if we omit them. Also true, they must be the trailing parameters because we cannot skip them and go to subsequent parameters. Flagging it as delete prevents its use, and it will generate an error if we try and use it. This is used to disable unwanted implicit conversions. Oh, meaning to disable unwanted or copy operations? I don't know what that is. To disable unwanted implicit conversions. Oh, the point is, it's so we're handling the type of information that we're passing. So, for example, if we have a function that takes a float, we could make an overload and delete it that takes a double. Make an overload that takes a double and delete it. Because we don't want you to pass a double, because the double will have a narrowing conversion unless it's known at compile time. So we can delete that to prevent that narrowing conversion from happening, that implicit narrowing conversion, which is a narrowing conversion. Yep. Overlay resolution rules are generally accurate. Oh, GG. Functions with a variable number of arguments? What? That's kind of cool. Yeah, I wonder how that works. Like you call something and then you just pass in however many. Well, I guess you could kind of do that with default arguments of 0. So you add 3 things and you call add 1, 2, and 3 and you get fucking 6. Or you could just do add 1 and 2 and it would actually be doing 1, 2, and 0. But then you have to add the exact number of things you're doing instead of just doing dynamically. Hey, I have 450 arguments. GG, buddy. Autodeduces the type from the initializer. Cool. Type def. Create type aliases. They're not strongly. Yeah, cool. Prevents narrowing conversions and causes compiling error if we would get narrowing. Cross expression and literals can help. Cool. Promotions are generally safe and well, generally, I mean, it should be always safe. Implicit conversions can cause data loss. Cool. I'll take it. Yeah. So runtime checks, static, and then debug. Assert. But not static assert. Well, yeah, that would make sense because if we're running it, then we don't want that code to run. But if we compile it, everything compiles. You're not going to be able to compile and then have the compiler ignore pieces of the code. Okay, I'll take it. Oh shit. And pages don't even exist. Alright, I'll take it. Seems good to me. Cool. I don't know how exactly I'm going to be continuing this. I think I'm going to be typing or maybe talking out loud in a room. Going to visit my northern half of the family, grandma and stuff tomorrow. So I don't know. I'll see. I should still be uploading. I might record a little bit on the plane, but doubtful. I'll probably try and sleep or something. I don't know. I don't know what I'll do. We'll find out. But KO. That's it. More tomorrow.